Hello and welcome to another video where I'm going to show you how to solve a reasonably tricky inventory domain problem using DAX. First of all, the inventory problem that I want to be able to solve is as follows. We have a set of data that looks like this. I'm going to zoom in. This is the same data that's in my blog where we have a unique number of test IDs. This is simplified down to be 6 unique test IDs, and for any given test ID it can work through a number of states. So for example, test ID A starts with state pending on 8 AM of the 1st of January, but then later on it goes into a new state and then another state, etc. What I want to be able to do is generate a measure that I can use in a matrix visual, or more importantly a chart visual, that shows for any given day how many of the states are valid. So we're going to drop the test ID, but we still need to have those into the mix to work this out. So this is my base data set, and the data model that we're using is a nice simple star schema. It's exactly the same table that I just showed you now, with some dimension tables to help clean the logic up. So let's go over to the canvas and start from scratch. So let's visualize the data straight away that we're working with. So let's unhide, view hidden, cool. So in the data table, what I'm going to do just to visualize on the screen is see for every single date time event that we have in a matrix visual, let's drag each of the 6 tests to the columns and grab the whatever state is in for any of these. Now I don't tend to like the totals. I find them distracting, so I'm going to turn those off now. Cool. Right, so what that means is when you look from the bottom up, we're trying to understand for any given day cutoff, what is the last known value for that. So if I was to just drag this up so we hide the 5th, for example, the value I want to arrive at for the 4th would be looking up, we see one value for pass, a next, a second next, a fail, and 2 more passes. So for the 4th, I want to report that we have currently 3 items that are in the state of pass, 2 that are in the state of next, and 1 that is state of fail. Now, when you look at another day, like the 5th, for example, you'll get different values and so on. So how do we achieve this in DAX? Now, a really good function that we use, and I describe this a little bit in my blog, is to take advantage of a function called the last non-blank value function. So what I'm going to do is I'm going to create a measure in my model, and I'm going to paste into that measure what we're going to call the step 1 measure. Now I'm calling this step 1 because we're going to work through this in baby steps. Now what this function does is it calls the last non-blank value DAX function, and we pass to this 2 parameters. We pass it a table and we pass it an expression. So let's have a look to see what this looks like when we put it into a measure in our canvas. So I'm going to click OK there, drag this over. Now I'm not going to use the date time column because the date time column is very hour, minute, second specific. What we want to do is we want to be able to represent this data by calendar day. So I'm going to use the date column from my calendar table. And when we turn this into a matrix, we're still not seeing meaningful values yet, because along my column header, I want to have a look to see what the results are for every single test ID. Cool. And I'll turn the totals off because I find them distracting. Boom and boom. Okay. So is this producing the right result? And let's bring this down. Wonderful. So we can see the measure and we can see the the results. Hopefully you can see this okay in the video. All right, so the 1st of January, we have 3 values for penned. And so for the 1st of January, we should have 3 values of penned. That's okay. For the 2nd of January, now the cutoff line here is we have 4 entries for the 2nd of January. For test ID A, penned is overwritten by next, but all of the rest of them are pending. And what we can see over here, for test ID A, it's reporting the correct value of next, and then the rest of them are now penned. Coming to the end of the 3rd, so we have another 4 entries on the 3rd. What we can see is A hasn't changed, B has changed, C has changed to next, D has also changed, E has changed, but F has not changed. So what we should end up with is 1, 2, 3 nexts, 2 passes, and a penned. And if we come over here, we can quite correctly see for the 3rd, we have 3 nexts and 3 passes. Is that right? Oh, and a penned. Sorry, I misread that. Yep, so we have the correct number. So this is looking pretty good. Now in the function itself, like I said, what we're doing is for the last non-blank value, we pass it, it requires a reference to an individual column, or you can pass it a table, but the table needs to have only a single column. Now the all function inside filter, what that's doing here is it's producing a table expression that has just a single column. It's grabbing every single unique value in this column here, and it's applying a filter to be able to say that let's go back in time. Let's take the value that's stored in the row header. So the row header here, which is calendar date, gets stored into a parameter. So here's the calendar date, gets stored into a parameter, and then we apply that parameter as a way to set the filter to say that we want to be able to use every row in the data column where the date time is earlier than the current date. We do the +1 just to make sure the boundary is set to midnight at the end of the day. So it's really saying, give me all rows from this fact table from whatever row we happen to be on and older. So that's the magic there. So it'll effectively discard anything from the future based on whatever a cell is parsing the calculation. Then what we do is for any given cell, we need to go and figure out what is the value in the state column. And we're quite correctly doing that here. Now we do need to apply a remove filters, because if we don't do this, what will happen is the value that we have here in this column in calendar date will apply to the calculation at this point. So we need to stop that happening, and I'll show you what I mean by that. If I take this down to a new column and comment that out, what we'll see is a different result, and effectively the value we're seeing is only considering rows from the fact table that belong to the state. It's not looking back in time. So being able to remove the filter context that's coming from the row header by using this remove filters function inside the calculate allows us to go and figure out that for all of our historic date times, what is the latest version for state. Min is not giving us the minimum state for everything historically. What it's doing is it's building a list of what are all the date times that belong to A, and for each of those date times that belong to A, so 8 AM on the 1st, 8 PM on the 2nd, 8 AM on the 4th, etc. For each of these that are on the stale before, go and work out what is the state that belongs to each of these times. So in this case, next would be assigned to this date, hour, date and time, and penned would be assigned to this. And then once that's done, it'll go and simply return what is the oldest or most recent. So let's go okay and go back to what we had. So far so good. This is looking okay. But for my visual, I don't want to I don't want to be able to pass in my test ID. I need to be able to remove the test ID, but what I do want to do is count the number and count and group these. So am I in the finished state yet? Can I simply remove the test ID, column from my column header and replace it with state. Let's just see what happens here. So if I, on my visual, get rid of test ID and drop state into here, we kind of get closer, but this is not working correctly because it's grouping these together. I'm losing the fact that on the 1st of January, I should have 3 pendings, not 1. Over here on the 2nd of January, I should have, I forget here, it's 5 pendings and 1 next, but I've lost that granularity at the moment. So what we're going to need to do is, while we remove the test ID from the column header, we're going to have to introduce that back into our DAX expression inside an iterator so that we can then perform a bit of a count function. So what does this look like? What I'm going to do is just copy and paste the next state into the measure. Now this doesn't look too different, only what I'm doing is I've introduced a new function called CONCATENATEX, which wraps around what we essentially had before. What I have bolded here is the same text from the earlier version of this measure. But all I'm doing is say what I want you to do is for every unique test ID in the test table, and we have 6, I want you to perform a loop. Now for each one of those test IDs, so for A, work this out, and then for B, work this out, then for C, work this out. But what I'm going to do is just concatenate the results of those loops with a comma separator to the screen. So if I click OK now, what we're going to see in the same visual, all right, we're going to see the data in the same column over and over again, but that's because we still have the state value in the column header, and it's influencing, it's actually affecting the DAX calculation. So let's remove that for now and have a look to see, are we getting the right results? So we are. 1st of January, we have 3 pens. And you notice that there are 5 commas. There's 1, 2, 3, 4, 5 commas. In fact, all of these lines have 5 commas, which indicates we're performing 6 loops of our iterator. 3 of the loops return a value. 3 of them return nothing. That's a good thing here. Then, for the 2nd of January, we perform the same 6 loops, but the first loop, which is for test ID A, and actually let's drop this in. What we can do to our test measure, and I didn't put this into our blog, which is kind of cool, is we can concatenate perhaps the, so what we have here is we can concatenate the test ID from here with a hyphen, so we can see between each comma which test and result this comes from. So this is quite cleverly using the string output of CONCATENATEX to help build a visual result set that we can use to eyeball and say, yep, we're getting the right value for A, the right value for B, the right value for C, etc. So here on the 2nd of January, test ID A is next. So this shows that we're working really nicely. Cool. So now we know that now that we're happy with that the calculation is working correctly with an iterator, we don't want to use CONCATENATEX anymore. What we need to do is use a different iterator to that allows us to perform a count function over. So I'm just going to grab the DAX function from the blog, Control paste. So the CONCATENATEX function has now been replaced with filter, and the beautiful thing about filter is what we can do here is apply a filter that allows us to match whatever we're going to be using in the column header, so that we can count these together. And this just gets counted with the count rows. So let's see what happens now. This is now called LBNV measure. We click OK. Okay. Now this isn't giving us the correct value, because what we now need to do is drag the state column, or the state comma, from the dimension table into the column header. And here now we have the correct result. We have 3 in pending for the 1st of January. We have 5 for the 2nd of January and 1 in next. So this is now working correctly. Let's have a look at the measure. What else has changed? Well, for a start, we have 2 variables at the start where we go and detect what is the selected value for the column we used on the axis, or in this case, the column that we dragged to the row header. we're also grabbing, and this was done earlier, the value for the column we used in the row header. So our current state was column header, current date is row header. Now they apply filtering. They naturally will automatically try and start filtering for any calculation that we perform. So that's why here in line 15 and 16, what we need to do is remove the filters just for the purpose of determining what should be the correct state from our fact table for every entry in our last non-blank value date time for the given state and date. Then once you've established that, now what we can do is work out, does the last known blank value happen to match the current state, which is the value in this case coming from the column header. If we drop this back now, there we go. So now what we should be able to do is take a copy of this visual, Control C and Control V. Oh, do this again. And turn it into a stacked chart. Drag the state back onto the legend. And let's turn on the label colors so that we know that we're getting the right values, and turn the label density for that to be higher. And we now have the correct values. So let's have a look to see how this performs over in DAX Studio. So I'm going to turn on my performance analyzer, start recording and refresh. We're going to grab the DAX query for the column chart visual and go over to DAX Studio. Here, I'm going to fire this up. It's going to be connected to my my data model, and I'm going to paste in the DAX query that I captured from the performance analyzer. And I'm going to turn on server timings up in the ribbon, and that's going to give me this tab down here called server timings. When I run the query, we can see that it takes not very long at all. There are 5 storage engine scans, but interestingly, one of these storage engine scans is in bold over here. And if I click on the entry in bold, we can see here that there is a callback, which isn't necessarily a bad thing. This is a very fast query on practically no rows of data, but if this was running over a much larger fact table with many more tests, this could potentially signal a problem in performance. So let's see what an alternative version of this DAX calculation might look like. So just remember, this is 5 DAX queries with a callback, and the result set, just trust me here that the result is the correct result that we expect to see for this visual. So I'm going to paste in an alternative version using top N. So copy that, paste it in, click OK. Alright, clear, refresh visuals, grab the DAX, copy query, and then jump to DAX Studio, and what we'll see somewhere up here, we're now using the top end function. Summarize columns, summarize columns, summarize columns. Where is it? Using top end. It's this one here. Cool. So we should still have server timings running. Let's run this now. And boom. It's only 4 storage engine queries. Previously we had 5 storage engine queries, and the one that we've lost is the entry with the callback. So this should, while it's running slightly slow, I mean this is just fractions of a second difference. I could probably run this 5 times and get slightly different results, but believe me, it's pretty good. How is this different? So coming back to top N, rather than use the last non-blank value, what we're doing is we're using the top N function here, which generates a table using all the columns from the data table, all rows, all columns. But what we do is we apply a filter to the raw fact table to say only consider rows that happen to be earlier than what comes from the row header or the axis. So that helps us by eliminating all future values. Then what we do is we also remove the filtering that's coming from the axis, the same way we did with the previous version of this. So this is quite important. And this top N also descends the date time value, or it creates a single column table, sorry, a multiple column table in descending order of date time. And we use the select columns to not add a column, but pull out of this table the value in the state, the value from the state column in the row, which happens to be the topmost row. We're ordering the table here in descending order and by date time, and we're just grabbing the topmost row, and then the select column function just goes and grabs the value in state. So this isn't doing a min or a max. So this is, I think, the difference between why we can get away with not using the callback, and we just artificially give the column a name which we don't use anywhere, and the rest of the function is the same. We apply a filter iterator to iterate through all test IDs to then evaluate what this expression is, and we then check to see whether the result of this expression happens to match the current state, the column that we're sitting in, or the axis. And if that does match, return a row. If it doesn't, return nothing. And then all we simply do is count the number of rows. So the essence of this version of the calculation works the same, and the numbers don't change. So that's pretty cool. So hopefully you found this video walkthrough useful. Some people I know do prefer to watch videos, some people prefer to read blogs. If you do have any questions or feedback, do feel free to provide these on the YouTube posting of this, or on the blog directly. So yeah, and let me know if you want to continue to get similar examples like this, how I solved it, in particular using baby steps, and yeah, I'm more than happy to do that. So thank you for watching. Cheers.